Hi, today we'll be talking about the different types of sensors we use and their applications. Sensors are extremely important as they allow a robot to respond to its environment based on the feedback that they receive. They are essential during auton since they are the way that the robot can determine its position and status so that it can react accordingly. Some examples of sensors being used are brake beams, which help during the intaking and outtaking of objects, and the Navx, which finds the robot's location on the field. All sensors are classified as either analog or digital. Analog sensors output incremental data or numerical values, whereas digital sensors output absolute data like true or falses and zeros or ones. All sensors connect to the RoboRio, which has two distinct sections for analog and digital sensor ports.
Another really powerful sensor is the Navx. By mounting it to the top of the RoboRio, the Navx allows the robot to navigate autonomously. This opens up a new array of capabilities for the robot. For example, the Navx helps with driving in a straight line and field-oriented driving. Furthermore, with the Navx, robots can also rotate automatically to a specific angle, balance automatically, detect motion, and even detect collisions. What makes the Navx so useful is that it has 9 sensor axes, 3 for the gyroscope, 3 for the accelerometer, and 3 for the magnetometer. First off, the gyroscope tracks the orientation of the robot in the yaw, pitch, and roll axes. All 3 of these axes are pictured on the airplane. In particular, the gyroscope tracks the rotational speed and degree of rotation in these 3 axes. Next is the accelerometer, which measures acceleration and tracks the velocity of the robot. Last is the magnetometer. The magnetometer tracks the robot's position in reference to Earth's magnetic field. Next up is the encoder. The encoder helps measure the angular motion of a robot shaft. Specifically, it tracks the position and speed with each rotation of the shaft. Such measurements are relative to the shaft's position when the measuring starts. Unlike potentiometers, which will be discussed later on in this video, encoders have no restrictions on the number of revolutions. The encoder senses mechanical motion and generates signals, which can be analog or digital. There are many different types of encoders, including, but not limited to, incremental encoders, absolute encoders, linear encoders, magnetic encoders, communication encoders, and rotary encoders.
The Hall effect is an analog sensor that determines if there is a magnetic field present and measures the intensity. It is often used to find the position of a manipulator on the robot by installing magnets in specific areas. In previous years, we used the Hall effect sensor to find the position of the elevator and determine whether it was raised or not. The Hall effect can also be an alternative to a limit switch if the sensor and its magnets are placed in certain areas.
Next, we'll be going over the brake beam sensor. So the brake beam sensor uses infrared radiation beams to detect when an object has passed through the beam. So this is a digital input system, which is a true or false system. True when an object breaks the beam and false otherwise. So how a brake beam works is that there is a transmitter and a receiver. One transmits the light, which has no function but to provide power for the light, and the receiver has a signal wavelength that determines what the sensor's condition, either true or false. And then there's another type of brake beam called a reflection brake beam, where the transmitter and receiver are on the same side, and the sensor defines true when a certain amount of light is reflected back from an object. And this can be modified. An example for this would be how your garage door system uses a brake beam sensor to detect whether or not an object is in the way of the door. And then the garage will stop power when the sensor reads true to prevent injury. The next sensor we'll be covering is the limit switch. The limit switch is similar to the brake beam in the sense that it detects when an object is at the sensor's position. This means that the limit switch has a digital input and output system. So how the limit switch works is when an object applies enough pressure, a metal filament will move to complete an internal circuit that will then send a signal that identifies the sensor state as true. There are different types of limit switches, 1, 2, and 3-way limit switches. but for the most part we used a two-way limit switch, which identifies only two states, true and false.